Well, hello again, and welcome to more amateur radio fun with Mk2. Now, I saw Peter, VK6PM, earlier today, and he said, I've got this old tuner here. It's an old Codan 7411 Mk2. It's a marine version, and I said, does that mean it's a ruggedized version? He said, no, it means it's painted blue. So just to let you know, it's a marine version. Now, he said, do you mind just taking it home and sticking it on that variable resistive load you've got, just like you did with the MFJ945E T-match, just to see if it tunes. So here we go. Now, this is not a T-match. This is probably an L-match, I would say, looking at it. Now, right, so I've set my resistive load. We're not going to give it a complex impedance, we're just going to give it a resistive load, 200 ohms, and we're just going to see how well it does at matching that 200 ohms, just like we did with the MFJ945E that made mincemeat of anything I could throw at it, really. It's really quite an impressive little unit. Okay, now just before I start, this is a switchable variable inductor. This is a variable inductor, which is a rotary wiper type. It's not a roller inductor, and this is a little bit gritty. This it needs a bit of a clean. This wiper on the inductor, I'll show you the inside in a second. And this here is a switchable. Does two things. It's a two-wafer switch. It switches the amount of inductance on this big coil here, and it also switches some capacitors in. You can probably just see it's a capacitor there as well. So there's a couple of things that does. Alright, so we'll start with everything in the middle, which is always a good place to start. And now, can we prop that up on the meter maybe, or better still, maybe a measuring device there. There we go. Right, be a measure of its ability to tune or my ability to tune it, maybe. Right, now here we go with the good old U-kits, and the U-kits is looking at 7093 megs. Okay, so I'm just going to try adjusting this one here. Okay, I don't know if you can see that, but just in that corner there something's beginning to happen. So I'll leave it on that one. Yeah, so that prefers that one. You can see, you may be able to see, there's just a little bit of something creeping in the corner up there. So 7093 megahertz. So let's try the rotary inductor. Oh yeah, so you can see something happening there. It's a little bit jiggly because the waveform's a little bit jiggly because the wiper on the inductor's a bit dirty, a bit gritty. Oh yeah, look at that. It's 1.3, 59 ohms. Oh, look at that. That's an SWR of 1, and 50 ohms. It's just jumping about a bit, but SWR is 1, and the impedance there is 47 ohms. And you can see that's a fairly broad tune. It's actually a wider bandwidth tune than we got with the T-match. So that's fine. I would say I could probably get that. Oh, that's me moving across my leather chair. Nothing to do with my high brown breakfast. Oh, God, these leather chairs smell terrible. Right. Now, what I should probably do is actually clean the wiper on that inductor, because I'm pretty sure if I did that, I could get that to 50 ohms. Oh, there we go. It's gone to 50 ohms. 50 ohms. SWR is 1.1 to 1. So that's very usable. No problem at all. And if I just tweak that slightly, I can get the SWR to go to 1. There we go. So the SWR is 1, the impedance is 45 ohms according to the gadget there. But as I say, it's a 200 ohm resistive load. But the bottom line is that is going to tune, that is going to present a load to your solid state transceiver that is not going to hurt it. There we go. As I say, that wiper just needs a bit of a squirt with Splonjo just to clean it up. Okay. Yeah, but that's, I would say that's a goer. 7.093. Maybe I should just get, I'm sure I've got some cleaning stuff somewhere here. It's fairly late at night here actually, so I don't have the crickets, but I do have the dog barking in the background. You can probably hear it. Yeah, maybe I should give that a clean. Obviously you'd have to clean it because you want it a lot more stable than that to actually use it, put any power through it. But that's certainly you can present 50 ohms to your radio. There we go. So you can present 50 ohms to your radio. SWR is 1.1 to 1, no problem at all. So this little tuner takes 150 watts. You could use it on 40 meters, no problem at all. Let's just see how it looks on 20 meters. Put that one back to there. I'm just looking at the impedance there as I do that. In the middle there. Back in the middle. I thought I saw 216 there. Yeah, the wafer switch is probably a bit, this probably hasn't been used for 20 years. 304, 240, okay, we'll leave it there. We'll leave that in the middle for now. We'll just try adjusting this. Let's try adjusting this inductor again. See if we can get anything in there. No, it doesn't like that very much. Okay, let's try. Okay, let's sort of. Yeah, that's God, it sounds terrible, that inductor, doesn't it? Ah, now that's what we got there. So that's with that's 50 ohms there. So that's with that maximum inductance. So I wonder if we get the maximum inductance on this one, and then bring this one back maybe. Certainly not as nice to adjust as the T-match, that's for sure. The T-match, the match just falls in. But sounds terrible, doesn't it? Yeah, so what you'd have to do is you'd have to make sure you had a tuning chart with this, because it's so finicky to adjust. So that's coming down 3.5, 2.4, it's gone to the green 1.6. So that's probably the minimum inductance there. That's a bit better. It doesn't look too... No. There's a 1.1 48 ohms. So you could use that. You've got this pretty big broad bandwidth thing here. This, I don't like the look of this very much. This what's sitting up in the corner there. Looks a bit strange. I haven't seen that before. But we are providing a match on 20 meters from a 200 ohm resistive load to the radio that would be acceptable. 1.2 to 1 SWR, impedance 45 ohms. I really don't like the look of that tune very much. Oh, that's a bit better. Yeah, it's still not. That's 1.9. 1.1. it prefers that one. Yeah, so it definitely prefers that input setting. Oh crikey, yeah, look at that. Now that's saying, that's interesting, that's saying the impedance is 50 ohms, but the SWR is 4.3 to 1. So I don't quite understand what that's all about, but a funny arrangement. Okay. But that's a better curve. I didn't like that squiggly looking thing on the side there. Can we tweak that with this maybe? No, possibly. Oh, that's better. 1.1, 56 ohms. It's a healthier looking tune. Yeah, SWR is 1 and the impedance is 48 ohms. SWR is 1, impedance of 48 ohms. So yeah, you certainly could use this to tune. As I say, this works up to 150 watts, so you could use it on a 100 watt solid state radio. Probably nice broad tune, look at it. I think I'd be inclined to tune it with an antenna analyzer and make a little chart of the settings, rather than actually adjust it with the transmitter transmitting power, because this rotary inductor, the wiper on it, I don't like that very much. And if it's giving, if it's going open circuit, even for an instant, the PA could be seeing that and it could upset it. So as far as it's probably designed to work with valve output stages, this thing, which wouldn't even notice that sort of thing, but these modern solid state radios might get a little bit upset. But you could, if you had one of these little antenna analyzers, or one very much like it, you can tune this and you can use this with your modern solid state radio. So if it will tune 200 ohms, it will tune 150, and it's not really worth setting other load resistances for it. I'm sure that would be fine. I can't remember if I mentioned it earlier. This here, it's there's actually a toroid, little toroidal core that the output runs through. Just a wire runs through the centre of the core. There's a few turns on the toroidal core. Comes up here to a diode. It's rectified, and it just shows you a peak amount of current. It's actually a current. It's showing you the antenna current. It's not in amperes, but it's just showing you as a relative reading. It's marked 1 to 100, and you just tune for a peak because that's the maximum antenna current, which is what you want with the type of antennas that are designed to go with this, which is I think it's 20 foot of wire or 9 foot whip or 20 foot of wire, something like that. So so there we go. Now I'll just show you very quickly what's inside it. How are we doing for time? 15 minutes, okay. I'll just show you what's inside it. Take my measuring device out of the way. Now, can I do this like this? There we go. Right. So there's my very professionally arranged connection to my load. Now, if my torch works, you can see in here there's an inductor. Now this inductor here is switched with part of this wafer switch here, so you can switch in all of the coil or half of the coil. This is the rotary inductor I was telling you about, and this is the wiper on here. As you can see, the wiper runs around here, and you can see why it was so jiggly. You can see why it was so jiggly to tune, because it's probably 30 years old, this thing, and it probably hasn't had a lot of use. Oh, I don't know though. Looking at that, it probably has had a bit of use, but just needs a bit of a clean up on there. You get some bit of grit and dirt between the wiper and the winding, and you get that spiky effect on the analyzer. There's the input selector inductance. That's a variable impedance transformer. That's just switching different ratios on this transformer. This little switch here, and there's a board here with a diode on it. Can't quite see it. There's a little diode behind there that rectifies the RF current. The actual RF output goes through this fairly thick wire here, goes up here, goes through this toroid here, and then out the other side, round here to the centre of this switch, and it either goes up to the top antenna post or down to the bottom antenna post, and that's the arrangement for it. So there we go, an antique antenna tuner. So it's not a T match, this will be an L match. An old Codan. Forgotten what it is. Hang on. Holding the torch between my teeth there. Obviously I'm not doing it now because I'm speaking. But it's a 7411 Mark II. You can read that. 7411 Mark II. So there we go. So if you saw one of those at a Hamfest for, I don't know, $10, I've just hurt its feelings now. And you're playing around with HF. You don't want to spend $500 on an antenna tuner unit, or $300 on an antenna tuner unit. You see one of these and it's a bit of a bargain. It's $10 or something like that, $20. Then you can get one of these, 7411 Mark II Codan, and you can get yourself on the air with it. As I say, I would recommend that you get yourself one of these little tuners, antenna analyzers rather, or something very much like it, so you can just cold tune it. So you can just cold tune it for the band or the frequency you're interested in, make a note of where these are set to, and then just have a little chart. This is what this is actually for. You're supposed to sort out the channels that you would use, because this is a commercial marine thing, so you'd sort out the marine channels you were going to use on it, and then you would tune it, and then you would make a note of these settings. So that's the load, that's the tune, and that's the antenna, and you would just put those, you know, you would put those numbers in there. So for the last band I used it on, which was I don't know, 20 meters, wasn't it? So load would be 8, and this